Hello, everybody, and welcome to another episode of Connect Conversation. Today's conversation is about maintenance practices, PM, PdM, and PaM. It's brought to you as a part of MOBIUS Connect's ongoing YouTube series, Connect Conversations. I'm Kim Fugger, the manager of MOBIUS Connect, and I will be your moderator for this session. First, I'd like to take a moment and introduce the host of Connect Conversations series, Global Reliability Improvement experts, Doug Plucknette and Ron Moore. Doug and Ron, are you both there with me today?
We're here.
Okay,
we
fantastic.
are definitely here. Hello.
Hello. Well, before I pass the microphone over to you guys, I want to encourage our audience here today to submit any questions that you have into the question panel on the GoToWebinar screen. And Doug and Ron will be more than happy to answer your questions throughout our time here today. Your questions will be answered on the air anonymously, so there is no need to worry about getting called out directly. Doug and Ron are here to provide their advice and perspectives from their experiences and are here to help you. All right, Doug and Ron, I'm going to pass things over to you.
All right. Ron, how you doing today?
Well, I'm here, so any day above ground's a good day. So, well, anyways, yeah, we're going to talk about maintenance today, I reckon, and that's really more Doug's forte, but I'll have to put in from time to time. So, anyways, whoever's listening out there, thanks for joining us, and whatever questions you may have, type them into the box, and yeah, that's done anonymously, as Kim said. So we'll be happy to try to answer them. So, Doug, you want to kick us off? You want me to?
Yeah, sure. When we talk about maintenance, we look at the different types of maintenance tasks that are out there. A lot of companies are overwhelmed by the emergency demand type maintenance task. And in reality, maintenance, for the most part, should be a planned and scheduled event, right? Something that you do to keep your equipment running. And so when we look at those types of tasks, our more proactive tasks, we have on-condition maintenance, which many of us in the business refer to as predictive maintenance or PdM. I've never been typically fond of that term. I've always liked on-condition better, but it's out there. You'll also hear people refer to as condition-based maintenance or CBM. And then we have preventive maintenance, which is known as PM. That's a time-based task. It's done on components that have a known age or useful life, and we hope that those PM tasks in most cases are measurable or quantitative. If they're not quantitative, then we look for something additional down the road to make the event repeatable. You'll also hear about failure finding tasks for hidden function devices and corrective tasks, which come as a result of your predictive or on-condition maintenance and your PMs, things that are identified through doing those other types of maintenance. Ron, any comments at this point?
Yeah, a couple, just one or two. I use the phrase proactive maintenance, and that's the PaM. Have a daughter named Pam. She's fairly proactive herself, but in any event, proactive maintenance, and in my mind, proactive maintenance is not so much about maintenance as it is about stopping the defects that create the maintenance requirement downstream, particularly the reactive stuff. So, changes, eliminate the defects that create the problem, changes to the design, the way you operate, the purchasing, the stores. And of course, there's some precision work that needs to be done in maintenance that very often gets bypassed when you're in a rush doing all the reactive stuff. So it's really important to stop the defects that are creating the maintenance requirement so that you can actually spend more time doing maintenance properly. So.
All right. And when you refer to proactive, this is one of those things. I just had this conversation with another guy that I consider a reliability expert, Tim Goshert. We discussed the difference between what you would call proactive maintenance and many call proactive maintenance and what others call corrective maintenance, right? If I'm out doing condition monitoring and I detect that something is loose or imbalanced and then put forth a task to go correct that, Some would call that a corrective maintenance task. Others call it a proactive maintenance task. And I'm the type of person that says, I don't really care what you call it, get it done, right?
Yep.
And let's make sure that it doesn't reoccur in the future. What can we do to make sure that that particular failure mode or condition goes away and stays away? I mean, that's the most important piece of this, right?
Well, just putting in, sorry to interrupt you, but I would call the data collection, the inspection, if you will, where you detect a problem, I'd call that a PM, because normally that's done on a weekly, monthly, quarterly basis. If you find a problem that needs to be corrected, I call that condition-based maintenance, because you found a condition that requires correction. The proactive piece would be going back and changing your lube, your alignment, your balance, your startup, your seal flow, whatever the hell it is, changing that so that you don't have that problem again. So that's the distinction that I would make.
Okay. And this is one of the things that's in our community that people do tend to get twisted sometimes around those words and what those definitions are. And I keep reiterating, I don't care what you call them, provided you get them done, right? So go out and identify. So looking at the first step, how do I go about identifying which task I should do to begin with, right? We can look at your OEM provides some recommendations. You can look at what most places do is they let things fail and then they decide, oh, we should probably do something about that. There are other proactive ways to look and say, how do we develop your maintenance strategy? What are your thoughts on that?
Well, so I've got several perhaps, but I'll throw out a few and then bounce it back to you. The one was when you mentioned OEM, what some of the studies by guys who are in the same field as you are, they're more RCM oriented. Steve Turner, I'm thinking of in particular, an Aussie friend. They've found that OEMs are right. Well, maybe I should say it differently. They're wrong a lot. So they're spot on maybe 35-40% of the time, and that's not because of any particular malfeasance, but it's because they don't understand your operating context, the consequence of failure, the environment that you're operating in, for one thing. And the second thing is they have a bias towards doing things more often because that's where they sell you more parts. So
there you go.
That has to be calibrated by your own experience and by your own operating context and what you're trying to achieve. So that's the first comment that I would make. The second one is on your inspection type PMs, or what I think of as inspection. Collecting vibration data in my mind is an inspection. It's not a predictive task, it's an inspection. You're looking for a fault and you've got fancy tools to do that. But that doing PMs, you have to have enough detail in the PM to know whether or not you have a fault, whether or not the machine or the process is in good condition. So your PMs have to have sufficient specificity to know if a defect is present or absent based on the operating conditions that you're in. And a lot of PMs out there don't do that. They have things like check coupling, check motor, check whatever. And what are you checking? Well, you're checking whatever the guy that's doing it thinks you ought to check, and that may or may not be the right thing. So those are
in some
just
cases,
a couple
it
of
might
comments.
just be, yeah, it's there.
Yeah, right. So, that's a really important point, though. Too many PMs say check what? And that has to be based on, failure modes and consequences and all that sort of thing, as you would know.
Right. And when you get to PMs, and I spoke earlier about them, the goal really your PM should be measurable if possible. And I've often had companies ask me, so what percentage should that be? And it's one of those where I just kind of touch my face and go, well, let's see, what percentage of your opponents are actually wear-based, right? And
Yeah.
even if they're wear-based, can you get at it to measure it? That's the second piece of it, right? If it's not possible to get at it to take a good measurement, then it might be something you consider for the on-condition task or the predictive maintenance task.
Yeah.
So,
well, and the other thing to throw in there, if I could, you know, the operating practices will and the installation practices as well, will very often affect, you know, the wear. So even if you have a wear-related failure mode that should be consistent, if you don't have consistency in your operating and maintenance practices, it's not going to do you any good. You know, you're going to fail randomly.
all right. And so going into those inspections in the operating context and how you operate it, one of the other pieces that I left out in discussing maintenance tasks are the operator care tasks. What are the things the operators could do? Simple lubrication, cleaning, and inspections that operators could do to not only discover failure modes, but prevent failures from occurring, right?
Yeah.
So that's another important piece that needs to be covered when you're developing that maintenance plan is what are the things my operators can do?
Go ahead.
Go ahead.
Well, just a caution on the operators doing lubes. If you have operators do the lubes, well, two different scenarios, and there are all kinds of extremes in between, or all kinds of, you know, variations in between. One is you got a machine tool, and it takes, you know, the machine tool lubricant and maybe a couple of squirts of grease or oil here and there to keep the machine running. Operators can do that. And that's fairly straightforward to train and to identify and all that sort of thing. If you're in a large, say, refinery or industrial complex, and you got 10 different lubricants and 2,000 machines and 6 operators per area and 4 shifts and 5 areas, well, the probability of error is about 100%.
So Ron, I see a question has come up.
Oh, well, yeah, here we go.
And it's to you. It says, Ron, did you ever perform a maintenance checklist prior to the asset being installed?
Have I personally ever done that? No. Have I seen it done? Yes. So, you know, for you folks out there that don't know me, I've actually never been a maintenance technician manager like Doug has. So he's familiar with all the details.
Yes.
But I have observed people do it poorly.
So the answer to the question from my end is yes, I've done that several times. In fact, I just finished one that turned out quite well. It helps if you have people that have worked on a similar asset or similar piece of equipment, for sure, right? And so they understand that how it's going to be run and what types of components are in there and what failure modes we would expect to see from that type of piece of equipment. So yes, this can be done up front, but it's one of those things that you have to have the right people in the room for sure to make sure you get a good outcome.
Yeah, well, you just mentioned it, Doug. The only other thing I would add to that is when you're doing these checklists, ask yourself, well, how does it fail? What's the consequence when it fails? You know, the standard RCM questions, and then put together a task that allows you to either avoid that failure mode or to find it early so you can mitigate and take countermeasures as to the consequence. So you might want to add to that. You're the expert in this area.
Yeah, it really is one of those things that the best part of doing this up front is that you can discover and eliminate several failure modes that come as a result of typically poor installation, right? If the installation is not done properly, if you're not using precision maintenance techniques, if the design in some cases was inadequate. We can identify those things up front, eliminate those failure modes from occurring, and then you don't deal with it. If you miss those things while it's being designed, while it's being installed, you typically end up living with that for the life of that asset, unless somebody opens their wallet to say, okay, we got to go back and correct this and make it right. And in most cases, that never happens.
Yeah, in most cases. So I don't know if you have a follow-on, whoever sent the question in. There you go. Here's one, Doug. There you go. That's one for you, Doug.
All right, I'm new to preventive maintenance team and pulp and paper factory and need to create a schedule. Can you list the top 5 things you would have on that checklist? Well, that's difficult to know. Looking in the paper industry, in terms of things that you should be doing on a daily basis, that comes into the type of product that you're running, right? And if you're looking at a schedule for what do we do daily, what do we do weekly, what do we do monthly, that's really a function of what RCM does. It builds a maintenance plan for you. Quickly, I would look at to see if I can identify where my wear-based devices are. Understand those. Those are where we would be doing PM and time-based type things. I'd look at the lubrication schedule up front. That's important. That's where a good percentage of our failures come from, especially in your industry, is I'll call it improper lubrication. Too much, too little, not enough, incorrect type. Lots of things fall into that. So look at that lubrication schedule up front. Make sure you consult with somebody that really understands lubricants, right?
And make sure your lubricants are filtered. Because
absolutely.
Most brand new lubes come in ISO grade crap.
Yeah. So the top 5 things on that checklist are going to depend on the criticality of what you're looking at over time, right? So it's difficult for me to say what would those things be. I'd have to understand what we're looking at. So, but I would look at developing that maintenance plan up front, look for what can we do in terms of our wear-based devices or our rotating equipment for on-condition maintenance. Then I would look for my PMs. And excuse me, even before that, between on-condition and the PMs, I'd put that lubrication piece. Go to that. That's highly important in the pulp and paper industry, is getting that lubrication under control. And as Ron said, make sure your lube room is up to standard, right? That you're filtering new lubricants coming in, that everything is clearly labeled. And this is a perfect place to be able to say, you need a lubrication technician, somebody that's MLT certified, that understands lubrication and knows what they're doing. That's going to make a huge difference in the life of your components for sure.
Yeah, and seal containers, color coded on the machine, minimizes the risk of error. I think that's really important. But by the way, I think Doug, I'll speak for myself. Anybody that just wants to chit chat about some of these issues, if we don't have time to cover them adequately, they feel free to call me. I'm assuming they could feel free to call you and have a much longer discussion. Yeah. So if anybody that feels that way, that's fine with me. So.
Email's great too. Mine is pretty simple, plucknette.doug@gmail.com. If you have any of those types of questions that you can't get in today, we'll certainly discuss any question that comes up.
Yeah. Okay, now where were we? So,
all right.
One of the things I wanted to mention here, the way I think of maintenance, and it started decades ago, is reactive, preventive, predictive, and proactive, with the predictive really being condition-based. Doug, I'm like you. I don't like the word predictive maintenance because it implies you can predict, failures and when they're going to fail and so on. You can know the condition and the severity of the condition with those inspections using fancy technology, and knowing the condition and the rate of change of the condition and the consequence, you can make judgments about how to minimize the consequence of failure. And so anyways, but I think in those terms, with the time-based stuff, condition-based stuff, and then the proactive things being a plethora of issues that you address. But the reactive bucket is the one you want to stay out of. You know, you can call all the other three by any name. Doug alluded to some earlier, but you want to stay out of that reactive bucket and put most of your effort into, you know, those, you know, basic care types of things, condition-based things, and proactive things.
Okay, and by the way, getting stuck in that cycle is what changes a maintenance organization into having a group of talented tradespeople to a bunch of component replacers. And when we become component replacers, then we stop talking about why things fail or what caused something to fail. And that's the most important piece as a maintenance technician you can do, is to understand the causes of failure, why things fail. Once we start looking at that, then we can start looking at eliminating those causes. In many cases, our causes are human error. They're things that we're doing ourselves, whether they came through design or through installation or how we operate it, right? Those types of things are what dominates the emergency demand maintenance that we see, right? If we don't install it properly to begin with, don't expect to get the life out of it, right? If we can't take the time to do precision alignment, precision balancing, to torque and properly use the correct pattern for assembly, the right gasket materials, all those things. When I go and I do RCMs with companies, those are what we talk about the most, right? And what do we need to do to step back and make sure we get the time to do things right? It's amazing. We always have the time to do things 2 and 3 times. We rarely have the time to do them right. And when we do them right, they last much longer.
Yep. I wanted to just make an observation to, you know, I suspect most of the people on here are maintenance folks. And a couple of observations. One is most of the reliability programs that I've come across have been led by maintenance. And I don't think that's the right thing, frankly, you know, just to be very blunt about it. I think, you know, most reliability programs are big on maintenance and actually small on reliability. And they really need to be big on reliability and in effect small on maintenance. And what I mean by that is that if you stop the defects in the design, in the procurement, and particularly installation, startup, and operating practices, you know, maintenance gets a whole lot easier. And if you don't do that, then maintenance is going to be really hard, and you're going to be constantly, you know, fighting fires and dealing with disruptions to your schedule and so on and so forth. Now, I don't mean to demean or put down maintenance. You've got to have really good maintenance practices. But they, again, I said this earlier, they get a lot easier if you tend to all those upstream things, because then you have the time to do all the things we've been talking about. So that's just, you know, that's a sermon you'll hear me preach time and again.
All right. So, and by the way, one of the best ways to understand that, what the maintenance role and reliability is to measure OEE. And I know we talked about that in a previous one of these sessions, so I won't go into it with too much detail. But when you look at your losses, try to attribute what actually came from maintenance and what came from poor design, poor installation, poorly operated outside of its design specifications, those types of things. And you'll find that maintenance is a much smaller percentage of those losses than most of the other categories. So moving back into our topic of discussion today with the types of maintenance tasks, I'm often asked, how do I know what technology to use or what technologies we should be using in our plant? And I always say, start with simple, work towards complex, right? There's lots of those tools out there that we can use to assess the condition of our assets, right? Starting with simple, I'm the person that says, Airborne ultrasound, very simple. Doug Plucknette even took that course and passed it, right? It's a tool that applies to, we can listen to bearings, we can find air leaks, we can determine whether or not an electrical safe cabinet is safe to open. We can use it to assist in our lubrication practices. So that's the technology I would probably start with first. Second, we look at infrared. This is one of those that when we look at cost and where it applies, many applications. So airborne ultrasound, infrared, then we get into things like, and I would even go to before this next one, I would say, let's get into process verification. That's using our PLC to develop trends for pressure, temperature, control, comparison trends, amp draw, timing. There's all types of things, we're calling those smart machines today, right? And that's really, all that information has been available for ages. Now companies are just getting the idea that let's start using it and putting it to use to our favor so we can understand the condition of our assets by monitoring our components while the system is running. So that would be number 3 on that list. Number 4, we get into vibration analysis, right? A little more cost, much more complex in terms of understanding, but well worthwhile when we get into looking at and understanding our rotating assets and the failure modes associated with those. Don't be surprised that when you get it, that you struggle up front, that you're going to find lots and lots of things that are imbalanced and misaligned. It's something that every company that gets into it early goes through. It's one of those things that I say, when we get that technology and we start using it, take it, your craftspeople, and show them the difference, right? Having been a tradesperson, I'm one of those that I learn best by looking at those examples. Take me out and show me what misalignment looks like or looseness looks like, and show me how to correct it and show me what good looks like, right? So how tight does that tolerance need to be? Is it plus or minus 5 thousandths, plus or minus 3 thousandths? Show me the difference, right? In doing that, you're teaching people to understand what they do makes a difference, right? And this is really a learning exercise. As Ron said, this doesn't all apply to maintenance, but I'm focusing today on the things that do, all right? Last one that I would get into that companies are involved in is motor current analysis. It's more complex, it's a little more expensive, but it's a worthwhile tool. The best thing is when we use these and compare with them, then we absolutely know that we're looking at a failure, right? Most important piece is what Ron talks about to begin with. When we go out and do these things, these are simply inspections. My hope is that when you go out and do them, you don't find anything. That means we did all our job the right way up front. But when we do find things, we need to plan them, schedule them, and get them done. That's where it makes a big difference. If we're not doing those things, we're just wasting our time, our energy, and our money. Any comment on that, Ron?
Just one comment on the vibration analysis. And this is in terms of setting expectations if you're already into this or getting into it. And that is that even the very best vibration analysis programs, predictive maintenance programs, if you will, the very best ones still will have a 5, maybe even 10% error rate, false positive, false negative. So
Sure.
In terms of creating the expectations, make sure people understand that this is not, it's more of an art in some cases than it is, 2 + 2 = 4 kind of thing. It's not determinative, it's probabilistic. And you've got such complexity in these machines that you just need to make sure people understand that, that it's, you may from time to time have a false positive or false negative.
Yeah.
And don't get all bent out of shape about it and just say, okay, what did we learn? What can we do to avoid that in the future? And then carry on. So
right.
And the others may have some similar kind of error rates as well.
So, and to help reduce that, that's really where you use multiple technologies, right? If you're first seeing a increase in vibration and you've got an alarm that comes in, now go back and look at what did our baseline ultrasound look like. Let's go out and put ultrasound on that and see what that says. What did our baseline infrared look like? Let's go out with a camera now and take a look at that. Using the multiple technologies helps to reduce that error rate. But you're absolutely correct. Even great programs will still see that the 10% false positive or false negative.
By the way, the same thing is true with doctors. So, and
Yeah.
tests that they do. just for your information.
Get another opinion.
So, one other thing I wanted to mention, Doug, has to do with maybe managing risk. The highest risk of inducing defects and failures is at startup. Installation, of course, because you induce defects when you do the installation poorly, but startup. And so what that means to me is you've got to have quality build plans when you do an overhaul on a major component. You've got to have precision commissioning and startup practices. You got to validate the quality of the work as you start up. And that can be something as simple as, maybe checking the motor for, inrush current and cross-phase impedance and all that sort of thing, and checking the vibration levels and make sure it's greased. Or it can be something far more complex in a complex system. So the data say that, you're something like 5 to 10 times more likely to induce defects during installation startup than you are during normal operation.
Yeah.
And that's a huge, strategic point to be made there in terms of how you set up your programs. And the second point I wanted to make is that after that, 80, 90, maybe 95% of failures are random. So it's really important that you have really good condition monitoring, both operations and maintenance, so you can detect those failures early enough to minimize the consequence of the pending failure. And which Doug's mentioned earlier, you really have to be tied into your planning and scheduling system, your work management system. So if you can address the infant mortality risk and have good condition monitoring, and then tack onto the back end of that a bit of a proactive attitude, you can really, do some wonderful things.
Absolutely, and that checklist that you talk about on startup is a huge and important piece. I always go back to a large tank farm project that I worked on that the first iteration of startup, so it went in 3 phases. They had several pump motors that were hooked up backwards. And of course, you know what happens to a centrifugal pump when the motor turns the wrong way, all right? And so, okay, for the next one, we're gonna make sure on our electrician's checklist that we bump that motor before they couple it, right? So we make sure it's rotating in the right direction. Simple things like that make a big difference. And yes.
We've got another question here, Doug. It says, if you only had an elevator ride to give someone a piece of advice about their maintenance program, what would you say?
Interesting. Wow. So my elevator ride would be, if you're getting into a maintenance and you have your maintenance program, my first question would be, do you have a formal apprentice program? Training is the most important piece when it comes to maintenance, right? So it's every place I go to, I ask that question, where are you getting your people from, right? Are they formally trained? In today's world, it's not that the devices are any more complex than they were 50 years ago. It's that the devices and the systems that operate them add more complexity to it. A pump is still a pump, a motor is still a motor, a valve is still a valve, right? It's how we measure and how we use these things together, right? And staying on top of that takes training. So we need to make sure people are trained to be able to do the work to the level of precision that's required to get that inherent design reliability that we look for. So if we don't have an apprentice program, what are you doing to get your maintenance people up to speed and to make sure that they all understand what good maintenance practices are? Your
Well,
turn.
that was more than a minute, but it's okay.
I got them by the back of the shirt before they get off on that floor.
Okay. Well, I did have one comment on what you just said, and that's this: that some of the studies out there have indicated that companies without an apprenticeship program have more injuries and higher costs than companies with apprenticeship programs. And so the point being, it's a really good investment to have a proper apprenticeship program. But now back to the 1 minute elevator speech or whatever it is. The big thing I would stress is what most of us are really interested in is high reliability. And I guess depending on who I was talking to, I would say, look, maintenance does not control reliability. They just don't. They contribute to it, much the same as accounting contributes to the success of a company. Reliability is controlled by a cooperative effort between design, production, and maintenance. And in existing operations is primarily having a good production and maintenance partnership so that you identify the defects, the failure modes, and you work collectively to address them. And if you do that, maintenance gets easier.
All right.
So
And
that's my nickel's worth.
We have another question.
Okay.
So my leadership team is resistant to invest back in our reliability program. Do you have any recommendations of how to show ROI, return on investment? I'm going to let you go first this time.
Okay. Well, you got to have some data to show the ROI. So I've got questions that you might want to try to answer to develop this. I would want to know what your OEE is and where your losses are. That'd be my first and foremost question. If you don't know that, I would do a business level FMEA that we talked about earlier to identify where the big opportunities are. And then with that, you can construct an action plan that demonstrates the return for having good reliability. Now, I've got a ton of data that says a reliable plant is a safe, cost-effective, and environmentally friendly plant. And you could use that data in general terms to demonstrate the value of it. Then there are other folks out there who have data on condition monitoring programs, on the cost benefit ratio. How much would it have cost you if you hadn't caught something? Those tend to be a little more circumspect because you can't put that money in the bank, So what's your OEE? What's the prospective benefit for improving that? Where are the losses? How are we going to manage those losses? And how are we going to work together with production and to some extent design to address those losses? And that's going to give you a good return. And you're not going to do that without improving the reliability of your plant. So those are the things I look at when I go into an operation.
All right, my answer would be similar. And the only thing I would add is people tend to try to manipulate OEE. I'm a person that says, buy Robert Hanson's book on OEE and do OEE Robert Hanson's way, right? Show them that this is a consistent way to measure your process or your machine or your equipment, right? And perform that on critical assets. And as Ron said, once you start locating the losses, the ability to impact those will become much clearer. And then you can start working towards that. When you work towards that, you'll be able to show that return on investment. What is that 1 or 2% or 5 or 10% of OEE worth, right? That's an important piece of being able to show that return on investment, is understanding what that value is. Sometimes those numbers are difficult to get, but I can tell you, you make a 10% change in OEE, everybody will notice it. Everybody that works there and works on that machine will see and feel the difference. right?
Yeah.
Whether it's from 40 to 50, 50 to 60, 60 to 70. The place that I just worked with was running at mid 90s OEE, and they said, hey, can you come in and help us? So imagine running that efficiently and still recognizing that there are gains and there's values in those gains, right?
Yeah. Let's see, we got another question. Our team struggles with getting ahead of reactive maintenance. Do you have any tips? Yeah, I've got one tip. Form, you know, this is what I think I would do, but I don't know anything about your operation. But what I've seen work very, very well is you pick a troublesome machine or process. You put together a cross-functional team and you go clean the damn thing. Now that may sound silly, but I can tell you, as you clean that machine, well, I ask you a question, what are you going to find as you clean it? You're going to find things wrong. And now that you've found them, and now that you've had some cross-fertilization of your knowledge, you're going to identify things that need to be corrected. So get it corrected. And then keep it that way. Put in place operating and maintenance standards and practices that keep it that way. Now that you've done that one, pick another one. And then you get that done, pick another one. And you just keep picking another one until you get through in some cases, the entire plant. May take you 2 or 3 years. In the meantime, you still got to address the reactive maintenance tasks.
Yep.
You can't not run the plant. So, but you're going to have to call out some time to go do things right. And I would take it machine by machine or standard by standard or procedure by procedure. Just chip away at it. Take small bites and keep chewing.
Right.
Doug, I'll flick it back to you.
Yeah, I agree with you 100%. Find the folks that are interested in helping you do that. Right. Look, this is one of those things that I can remember going through as a tradesperson when we first started looking at. Number one, we got the CMMS and we all hated it. Right? Well, it's just a waste of time putting all the information in. Well, then once you realize that it's actually a tool to help you, right? That you can go in there and say, where are we spending the most time? What are the reactive things that are spending the most time and the most money and happening the most often? Identify what those are and start working at those, right? It's a different way, a different thought process of what Ron said of cleaning the machine and go find things. That information should be in your CMMS. So that's one way to get started.
Yeah.
I can tell you that, the work group that I had, we had 28 people, and there was more than half that were interested in saying, we got to make this place better, right? And we took just that little bit of time every day to talk about what are some of the things we can do that make things better here, that'll make things run better, right? And just in small groups, attack those things, right?
Yeah.
You'll find there always is a little bit of time. You may not have 2-3 hours to work on something, but you'd be amazed at what you can do in those 15 to 30 minute intervals where you say, what can I do to make something better? All right. There's a lot out there, and most plants, especially those that are in that over 40% emergency demand maintenance, right? I can tell you that plant that I started in, we were probably near 70% emergency demand when I started there. But the right group of people focused on making things better made a huge difference. And we set records there, one record after another, just by working as a group. And that, by the way, wasn't just maintenance people, it was the operations folks too.
Yeah, cross-functional teams. I think I said that, but if I didn't, it has to be that way to get that collaboration, cooperation, and sense of purpose amongst the folks operating the line and maintaining the line. Yeah. I see we had a question. Whoops, it disappeared. Wait a minute, let me go back. Hold on.
What opportunities?
So my plant uses time-based maintenance, TBM, which is performed on equipment monthly only. Is that a correct use of TBM? Whoa, I'd say you're wasting a whole lot of time and energy, and you're not finding the stuff you ought to be finding in between. That's my guess. Doug?
Yeah, time-based maintenance only is way too much.
It's
You
not
know,
smart. Let's say it that way.
yeah, and this is the thing. Again, when you look at terms, it's one of those where, I wish the person was here to ask directly. When you're talking time-based maintenance, is that PM and on condition or predictive, right? If that is, then certainly a higher number is acceptable, but only? No, I don't think so. Right? There's many other types of things that can be done, and there has to be, out of those time-based tasks, there has to be those proactive or corrective types of tasks that come to make the equipment right again, right? To eliminate that defect.
Yeah.
So
let's go back to something I said earlier about this. I think this is just not the right thing to do. Now, I don't know enough to know for sure, because like Doug said, I don't know how you're defining this, but doing something once a month on a specific time basis, if it's inspections and checks and filter changes and all that, that's probably a good thing. But if it's doing intrusive stuff without knowledge of condition, that's not very smart.
no.
Because remember, we said 90% of equipment fails randomly after you get through that infant mortality period. And if you don't address
Yep.
the infant mortality period, you're going to induce a lot of random failures. So getting the installation startup right and then doing condition-based stuff after that is the appropriate approach here. So now, if it is a consistent wear base, like wear on a slurry pump that's operating continuously, then that's okay to do time-based replacement. So, anyways, we're starting to run a little short of time here, I think. No, we're good. We're good for now. Okay.
Yeah.
So I hope that answers the question, but whoever asked it, if you want to call one of us, we'll be glad to talk some more. Next question is, what opportunity lies for achieving reliability through digital transformation? Well, I'm not in a position to answer that. This IoT stuff gets a lot of press, and I would suggest that you probably ought to talk to somebody else beside me. I just want people to put the right lubricant in the machine at the right time, and to balance it, and to make sure that you don't have excess cross-phase impedance on your motors, and just the basic stuff. So,
All right, I just did an article on this with Tim Goshert that for a company called Proactive Reliability, and here's the thing: all this stuff is exciting, but it changes nothing in terms of reliability if you don't have the foundational elements in place. All right. So all we have, and I talk about this is really, people get excited about new things and new technologies. We got excited about the CMMS when it came out. And in reality, CMMS had no impact on reliability, right? It was a tool. And that's what all these other things that people are talking about are just simply tools to give us more information to work with. So will that help? It'll help if you have the right things in place. It'll help if you have a good hierarchy, if you understand the criticality of your assets, if you have a method or way of developing your maintenance plan, if you have a way of seeing that maintenance plan through. Same thing on the operation side, how we operate that equipment, right? If our operators aren't trained on how to interact with that new smart machine, they're going to do things the same old way, right? And eventually, and this is what the company that I worked with saw, they said, come in and do our new smart machine. And I cautioned them, I said, look, all these bells and whistles on this thing are fantastic. And we were doing this analysis prior to the machine actually being on the floor. I said, my worry is there's so much here that your operator may end up going into this HMI, and if you allow them, ignoring or disabling these alarms because there's so many of them. They need to understand what caused it, what do I need to do to rectify it, all those types of things. So is this exciting? Absolutely it is, right? It's more information is simply what it comes down to. So how do you deal with that information? Are your people trained to deal with that information? What does it mean? If they understand that and they're educated in it, this is going to be a great thing. If they're not, if we continue to do things the way we used to do them, it's going to be something that gets ignored. And I hate to say that.
Well, just,
I want it to work, right? But
Yeah.
train your people and it will.
There's been on the SMRP open forum or whatever it's called, there's been a lot of discussion about IoT and analytics and CMMSs and setting up databases and so on and so forth. And, that's all really important. Okay, I don't want to demean that. It's really important. On the other hand, what I see happening a lot is people spend a lot of time doing the engineering analysis of the data and the analytics and all that stuff, the mechanics, if you will, of using a CMMS or analyzing the data. And that's all good stuff, but not nearly enough time just doing the damn basics right. You'll get that right first, and then that'll be a lot more meaningful, I think, when you analyze the data and you have more time to analyze the data. So I wish I had a better answer for you. I'm not the one necessarily to answer that question. Doug, are you still there, or have we lost you? Uh-oh. Doug moved his computer, so I guess I'm the only one active. Now, was there a follow-up question on that digital transformation? Talk to folks, get the basics right first. It's the old, whatever, data in, garbage in, garbage out. Get your garbage lined up first, so you put proper information in first and do the basics right, so that you'll have more time to do the analytics. So, well, I don't know if Doug's coming back. Let me look at the time here and see if we got about 4 or 5 minutes to go. Yeah.
No, Ron, thank you so much. I do see Doug is still off, but we'll go ahead and close things up today. You guys have answered every question that came in. So thank you both for another great conversation.
Well, we tried to answer.
You did a great job. The audience is thanking you, so we really appreciate it. Is there anything you would like to add before we wrap things up?
I'm just looking. I've got a little checklist. I believe, use checklists to make sure you're doing the right things when you install and start up this stuff. I scribble a little checklist before each one of these, these webinars, podcasts, whatever it is. And I think we pretty much covered the things I wanted to touch on. I don't see anything there I would do differently, or add to it. So I think we've covered things that I wanted to touch on.
Great. Thank you again, Doug and Ron, for your time in this awesome session. On behalf of the entire team at MOBIUS Connect, thank you to our wonderful audience for joining us today too. Just as a quick reminder, you can see past episodes of Connect Conversations on YouTube, and we will share the link to subscribe to our YouTube channel in an email following this webinar. Be on the lookout.
Oh, Kim, one other thing, you can share with folks our contact details, email and phone number if you want. That's fine with me.
Thank you, Ron. Yes, we can include that in the follow-up email as well. Please be on the lookout for all new episodes. We typically air them every Tuesday at 2 p.m. on YouTube. And
every other Tuesday.
Every other, did I say every? Yes, every other is correct, Ron. And if you are interested in engaging with other industry professionals or would like to participate in the industry's live feed and forums on MOBIUS Connect, you can visit www.mobiusconnect.com to create your free profile, and be sure to follow us on social media at MOBIUS Connect to stay up to date with the latest community happenings. And if you have any questions at all, you can email the MOBIUS Connect team at info@mobiusconnect.com. Thanks again for joining us. Have a great day. Stay safe.
Thanks everybody for joining us.
And we will see you guys next time.
See you in 2 weeks, I hope. Take care.
Thank you. Bye.
Bye. Doug's back just in time to sign off.
He is. Well, Doug is back. We'll just let Doug take a second to say goodbye too.
Say goodbye, Doug. Nope. Headset's not on. I guess he can't hear us. Maybe he doesn't know we're here.
Maybe he doesn't see us, but all right, you guys, we'll end for today. We'll make sure Doug gives a nice little shout out here and says goodbye. Have a good one.
All right. Bye, Kim. Thanks for your help.
Thank you, guys.